Good day. Our lesson for today is titled Finding Answers Through Data Collection. Welcome to the third week of second quarter, and our lesson for Practical Research 2 is about the part 1 of data analysis. In this lesson, we are going to talk about the different methods of data processing. Data collection is only half of the picture when it comes to results and discussion. Definitely, you need to gather data through several means like experimentation, survey, observation, and the likes. However, the data gathering does not end there. It's only just half of the picture. All right, what should happen next? There must be the analysis of those data that you gather. The information is meaningless until the numbers are reduced, condensed, summarized, analyzed, and interpreted. So before we proceed with the analysis per se, it's important to process the data. So we have data processing. It's about dealing with editing, coding, classifying, tabulating, and presenting data through charts and diagram. We use several ways of processing data. All right. Here, there are a series of actions or steps performed on data to verify, organize, transform, integrate, and extract data in appropriate output form and subsequent use. The methods of processing must be rigorously documented to ensure the utility and integrity of the data, because even at this process, we can already see the validity and reliability of the data. If there is something wrong with how we manage, with how we deal with the data, then the results may be affected. It may be invalid in the end. Translating information can be done either through manual or electronic means, okay? And it can be qualitative or quantitative in nature. What are the steps in processing the data? You need to classify or categorize the data first. Then you need to code the data. You have to listen down and then tabulate them. For classification or categorization, this is the process of grouping the statistical data under various understandable homogeneous groups for the purpose of convenient interpretation. So kailangan ninyong mapagsama-sama yung mga data na may pagkakatulad or similar ng ina-represent na values or pinapakitang resulta sa atin. For example, you need to group them. Are they considered to be categorical data? Are they discrete and continuous data? Should you classify the data as nominal, ordinal, or ratio and interval? Now you have to take note at the criterion. The uniformity of attributes and similarity of the data must be looked into. For example, yung mga demographic data like the age, the sex, the marital status of participants. How are we going to categorize those data? The scores, the measurement, but those observed data that we gather, how are we going to classify and categorize them? After categorization, you need to code the data. So it must be translated in written format so that it is easier for analysis and visualization later on. This is, again, necessary for efficient analysis. Kasi kapag naka-code, it's either typewritten, handwritten, basta it is in written format, mas madali na siyang i-organize in the next processes. This is the process also of converting words, images, or pictures into numbers if we're talking about quantitative research. Yan. For example, diba, one of our question is the sex of the respondents. Are they male or female? And if they are male, we will label that as 1. And if they are female, we will label them as 2. If we have educational degree, for example, kinder is labeled 1, elementary graduate is labeled 2, High school graduate is labeled 3. College graduate is 4. Postgraduate is labeled 5. Okay? Another is their occupation or profession. So for example, they are in the medical field, that's labeled 1. Engineering, labeled 2. Education, 3. Business, 4. So this is very important, no, to assign number in our qualitative data, in our measurement, again, because it will be easier for us to arrange them, present them, analyze, and interpret them. For qualitative research data, we also do this coding. If you can remember last year. So we identify string of text, string of information from the interview, from the survey or essay, whatever means of data collection you use. We assign codes to them, and then we rearrange the codes and find the similarity, find the connection among the codes. That is almost similar in quantitative research. Only this time, the codes that we are assigning the data that we gathered are in numerical form or numbers. After that, we are going to do the tabulation of the data. This is the process of summarizing raw data and displaying it in a compact form for further analysis. So after we assign codes to the data that we gathered, we have to arrange them in table form. It may be done manually, mechanically, or through electronic means. It is based on the size and type of study, the alternative cost, the time pressure, and availability of computer and other programs. It can be a simple tabulation. For every question, you have a tally, or you have a table, or you have a chart for your certain information. Or it can be a complex tabulation wherein you are going to combine several questions in one table or data set. We may also use data diagram in presenting our data. So we may use visual ways like pie chart, bar graph, histogram, line graph for us to have a better visualization of the data. It helps us present the data more concisely and clearly. Once we are done with the categorization, with coding, and with arranging our data, tabulating our data, then we may start the data analysis. So what is the scope and the purpose of data analysis? First, it is the data analysis is the process of developing answer to the questions, to the examination and interpretation of the data. So after we present the data, we look at the details that the data is presenting us. What are the high points, the middle points, the low points? Are they showing us connectedness? Are they showing us cause and effect relationship based on the values that we gathered? The data were presented in a clear and concise form, which mostly uses graphs and tables. After analyzing each part, so in analysis, we look at each part, we used to look into every detail of the data. We have to proceed to interpretation after that. In interpretation, we have to reduce the data into an intelligible and interpretable form so that the relations of research problems can be studied and tested and conclusions can be drawn. So after you spread out the data in the analysis, you after looking at them into pieces, looking at them every detail, every part, we have to put them back together again to create one meaning out of that data, and that's what we present in the interpretation. And we find out whether our hypothesis is true or not based on the analysis and the interpretation that we can get. The data interpretation refers to an adequate exposition. You are going to reveal the true meaning of the material presented in terms of the purpose of the study. At this point, are we going to accept the null hypothesis? Are we going to not accept, no, fail to accept the null hypothesis based on the data. So this is very important that we have to decide what is the data is telling us. So that's what is in the interpretation. It is also important to match the analysis strategy to the research problem. Okay, so if you're asking for difference, you have to present difference in your interpretation and analysis. If you're asking for correlation, then it must be revealed and discussed in your interpretation. If you're asking for cause and effect relationship, that must be determined in the interpretation of your data. So what are the steps for data interpretation? First, you have to revisit the main and the sub-problems. Again, as I have told you, the interpretation must be aligned to what you would like to answer or solve in your research. So balikan natin dapat yung ating research problem. And then, describe the data. After that, you have to plan an appropriate way of presentation. Should you present it using graphs? Should be presented in tabular format? What are the contents of the table? How is it going to be arranged, and so on? Plug in additional information. So this time, you are going to compare it with existing literature, find explanation to the data. You may also compare it to the theories, to the statistical or the demographic data of the research. You may also try to compare one data from the previous one that you have already presented. So to make the discussion rich, and you need to have a closure or concluding statement in every data interpretation. Again, this is when we are confirming whether our hypothesis is correct or not. Here are examples of common statistical tools that we can use for our data. First is the use of averages or central tendency, the mean, median, or mode. It is useful in determining the overall trend of data set or providing a rapid snapshot of the data. So if we are going to combine them together, what is the central idea that the data is presenting? So it can be a mean, can be median, or it can be the mode. We can also use frequency distribution. This is commonly presented in tables or charts that show how many of the data, how many of the participants fall into various categories of interest in your study. We may also use pie chart. So ito naman para ipakita natin yung percentage ng bawat category. And we have bar chart that is equal to frequency in category. However, there are spaces in between the bars to emphasize that there is no ordering in the classes. In frequency distribution, for example, a histogram, there is no space because it represents continuity. But for bar charts, it is separated because each bar is an independent category from each other. So what are the things that we can do in the data and the statistical analysis of the data? In the statistical analysis, we convert numbers into meaningful conclusions. Again, in relation to the goals of the study. Kaya nga kanina, kailangan talaga nating bumalik sa research problem. Kasi we have to make sure that the statistical analysis we are applying, the interpretation that we're doing in our data really answers the questions, really achieves the goals of the research. Proper development of research proposal is dependent on what kind of data you will collect and what statistical procedure exists to analyze the data. Kaya din meron tayong classification and categorization ng data because there are appropriate statistical analysis for different types of statistical data that we gather. Okay, kaya nga ginagawa natin yung preparation kanina, no? Yung categorization, yung coding, and yung tabulation ng data. Yan, we have to give emphasis on this part. Dapat sigurado tayong tama yung data analysis based on the data available. Or else, invalid yung magiging results ng research. There are two types of statistical analysis. We have descriptive. It reduces data or raw data to more meaningful form. Diba? From if you, for example, you have 100 respondents and they have different scores, we arrange them, we organize them so that we can see what is the picture that these values are showing us. So that is descriptive analysis. Diba? It tells us what is the behavior, what is the characteristic, what is the commonality of the participants in your study. In inferential, it helps us interpret findings from a smaller group to a larger one. In the inferential statistical analysis, it allows us to predict what may happen in the future by finding relationship, comparison, and cause and effect relationship of the data. It may also help us know whether the findings that you gathered in that group is applicable to the population at large. Because remember, in your data collection, most of the time you do not get data from the entire population. You only get data from sample, representative of the population. So in the inferential statistics, it will help us know whether the data that you gathered from the sample can be generalized to the population that you are targeting in your research. For descriptive statistics, we have mean, median, mode, standard deviation, variance, and range. For inferential statistics, there are a lot. Common examples include t-test, ANOVA, chi-square, and correlation. Again, this depends on what you would like to prove or to answer in your research, and at the same time, what type of data you have. For the types of data, this is just a recall. We have nominal, ordinal, interval, and ratio data. Nominal, this is the weakest form or the weakest type of data. Attributes are only named. So variables which are categorized into discrete group. And when we assign number in a nominal data, okay, subjects are simply grouped or classified into categories on the basis of some particular characteristic, and the numbers really do not tell us any numerical value. Diba? Talagang pang-label lang siya. Diba? For example, we label male as 1, female as 2. It doesn't mean that male is less than female. Or kung baliktad sila, female yung 1, male yung 2. It doesn't mean that 2 yung male, mas mataas siya or mas malaking value niya sa female. It's just a number to label them. For example, we have the data about the leaf color due to application of certain fertilizer on plant. And we have different plants that receive different types of fertilizer. So plant A, the color of the leaves are dark green, 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 dark green, and green. For plant B, it receives another type of fertilizer. So it has different set of colors of leaves. Plant C, D, and E. So we can, if you're going to look at the data, there are 4 possible colors of leaves. Dark green, green, yellow, green, and yellow. So we can assign dark green as 1, green as 2, yellow, green as 3, and yellow as 4. Again, the numbers does not tell us any numerical significance. Okay, it's simply just a labeling the color for us to have a better analysis of the data or a better organization of the data moving forward with our results. So we can now transform this data to this. Okay? With that, it will be easier for us to arrange how many got 2, how many got 3, how many got 1, and how many got 4. Okay, so for the analysis later on, it will become easier. Next, we have ordinal data. So in ordinal data, variables are ranked or they are arranged in order. The orders of the subjects are from high to low on some variable. If in nominal data, we use the number to simply label or categorize them. Now, the number here in ordinal data has meaning in terms of sequence of arrangement. For example, if we are going to rank different materials based on their urea amount, let's say we have 5 types of fertilizer, commercial fertilizer, lemon rind, tomato flesh, banana peel, and potato skin, and we get samples of this 100 grams for each type of fertilizer. We determine the amount of urea present in every 100 grams, and we found out that commercial fertilizers rank first. It has the most amount of urea. Lemon rind is second, tomato flesh is third, banana peel is fourth, and then potato skin is fifth. We can also use this for behavioral information. Say, for example, happiness level. If an individual has a score of 5, it may mean that they have very high happiness level. 4 is high, 3 is moderate, 2 is low, and 1 is very low. However, we cannot determine is the distance of very high and high equal to the distance of high to moderate. So we cannot tell the interval or the distance of the score. We can only determine its order. Pwede ba nating sabihin na 4 times happier si very high than very low? We can't. We can only say that very high is definitely higher than very low because the score is 5. But how high is it than the other categories or description? We cannot tell. We can just simply know the order. The next type of data is interval. Now, the distance between data points have equal or fixed gradations. So the distance between 1 and 10 is similar to the distance between 11 and 20. Numbers are associated with these fixed gradations or interval. So if you have the score of 1 to 10, the distance of 1 to 5, so that's 1, 2, 3, 4, 5. So 4 steps from 1 will have the same distance from 5 to 6, 7, 8, 9. 4 steps din siya. Okay, so the points, the data points, the graduation is equal in terms of interval. Kaya kasi tawag na interval data. For example, the flowering temperature in Celsius. Yan. So here are our data. Okay. For example, dito sa subject 1, it has 20 degrees Celsius for commercialized fertilizer, and then for tomato 24. So it means that it is 4 degrees Celsius higher than 20 than a commercial. For banana peel, it's 22. It means it has 2 degrees Celsius. It is 2 degrees Celsius high than the commercial. For lemon rind, they are equal because they are both 20. For potato skin, it is 1 degree Celsius higher than the commercial, than a plant which use commercial fertilizer. Lastly, we have ratio data. So this one, it has almost similar characteristics with the interval. The distance is meaningful. The interval from one point to another is fixed. However, ratio has absolute 0. Okay? The 0 point is meaningful. It may mean the total absence of a certain value or a certain measurement. A true 0 point means that the observation can be compared as ratio or percentages. For example, if you're using a Celsius data for temperature, that is interval because 50 degrees Celsius is, or say 100 degrees Celsius is not twice as hot as 50 degrees Celsius. We cannot tell that because there is no fixed 0 point that can be the basis of the ratio or proportion of the two measurement. So hindi natin pwedeng sabihin na doble yung init niya kapag 100 degrees Celsius from 50 degrees Celsius. Pwede natin nadagdagan siya ng 50 degrees, but we cannot say that it is twice na double yung init na meron yung material. But for ratio data, for example, naglakad ka ng 5 meters at yung kaibigan mo ay naglakad ng 10 meters, pwede natin i-compare na doble nung layo na tinravel mo yung na-travel ng kaibigan mo. Yun yung sa ratio data. For example, the plant height in centimeters, ayan. So, for commercialized fertilizer, for example, we go to subject 1, 90 centimeters. Okay. Tapos, ito ay yung tomato flesh is 44. So, if we are going to compare, di ba, this is yung commercial is almost twice as much as the tomato flesh fertilizer. Kasi 44 times 2 is 80. So, di ba, almost twice siya noong sa tomato flesh. For tomato skin, if we're going to compare that to 90, we can say diba, that it's almost 3 times as much as the potato skin. So yan, pwede natin compare yung ratio kapag ratio. After knowing the type of data, we can now subject our data to descriptive statistics. Again, we may use measures of central tendency or the averages, such as mean, median, and mode. We may also use measures of variation, such as the range, the variance, standard deviation, frequency, distribution. For measures of central tendency, we have the mean. This is the most powerful measure of central tendency. This is commonly used for interval and ratio data. So the average value of all the set of data. What we commonly do is we add all the data set and divide it by the number of sample or the sample size. For median, it tells us the middle value once data is arranged from highest to lowest. Half are above the median and the other half are below. So median is better used for ordinal data kasi nga we arrange the data in order and we pinpoint the middle value. We can also use median for interval and ratio data, but it is better used if the data is skewed on one side, left or right. Yung mean, maganda siyang gamitin kapag normal distribution yung ating data. Pero, say for example, Makati Science High School, commonly mga estudyante may mataas na score, aptitude in exam. So they are leaning on one side commonly. So mas magandang gamitin yung median kaysa sa mean. Diba? For example, halos lahat ng score ay matataas. So they are leaning on just one side of the scale, of the range. And then kapag ginamit mo yung average, it will not have much meaning kasi magkakalapit na yung score nila at halos lahat nasa taas. So it's better to use the median. And mode, this is the value of the variable that occurs most often. Ano yung madalas na lumalabas? This is better used in nominal data, especially when we get frequency. Diba? Sino mas marami, male or female? Ano yung mas marami na respondents? For example, adult ba, Gen X, Gen Z, or Gen Y? So, yeah, it's better used in categorical data such as nominal and even in ordinal data. Now, what measures of central tendency is appropriate to use to the following? For the height of plant, we better use mean because height is ratio data. Number of leaves per plant, we also use mean. Again, this is an example of a ratio data. Pag ratio, there is fixed 0. If the height is 0, ibig sabihin, hindi nag-grow yung plant. Diba, walang change in the height. For the number of leaves, kapag 0, ibig sabihin, wala talaga halaman or wala talaga dahon na tumubo. So, comparing the data that we gathered in terms of number of plants, it's better to use the mean. Flowering time. When is the best time that the plants develop flower? In this case, we use mode because flowering time is simply a nominal data. Number of pods per plant, we better use mean, just like the number of leaves. And the total weight of the plant, we may use mean. Similar to height, weight is an example of a ratio data. What about temperature? Temperature is an interval data. What is the best measure of central tendency for that? You are correct, that is the mean. So again, for nominal data, it's better to use the mode. For ordinal, mode or median. For interval, we use the mean. Ratio, we also use the mean. We can also use median for interval and ratio data if they are skewed on one side, on the left side or on the right side. For the deviation of measurement, one thing that we can get is the range. This is the difference between the highest and the lowest value. And this is the simplest way to estimate variation. So for example, you have this data. 23 is the smallest value that you gathered. You simply subtract it with the highest value, which is 76. And that is the range. Of all the data about variation, this is the least reliable. We have frequency distribution. This groups the data into different classes in tabular form. It denotes the number of cases or subjects that will fall in each category of the variable. Para makita din natin yung if the distribution is normal, is it following a normal curve, is it leaning on one side, scattered ba masyado yung mga respondents in the different categories, and so on. This is a very good way to visualize variation. So for example, we have plant height in centimeters and we have 42 plants. Ayan yung data na nakuha mo. Okay, we can arrange that in the form of table. So the highest score is 48 and the lowest score is 21. So we can set class intervals. The highest point is 48, the lowest point is 19. The lowest score is 19. So we arrange them. We have class interval, then identify the midpoint, and then determine the frequency that is present in each class interval. Okay? So dito makikita natin, aling class interval yung mayroong pinaka-mataas na score. So yun yung 9. Okay? Alin yung mayroong pinaka-mababang scores or frequency na nakuha. So itong 43 to 45 kasi isa lang. So that is a frequency distribution table. We can also present this again in a form of histogram, diba? Para mas makita natin yung, or pwede rin bar chart para mas makita natin yung curve, ma-visualize natin yung talagang actual distribution niya using bell curve. And we have variance and standard deviation. So variance is the average of the squared distance from the mean. And standard deviation is the square root of the variance. So this, kung square distance from the mean, yung variance, standard deviation is the distance from the mean. Kasi nga, square root of the variance siya. Okay? These two are accurate measures of variation. Kasi nakikita talaga natin gaano kalayo yung isang score or yung isang point or isang data from the mean of the data. This means that we have to get the central tendency of the data, most specifically, the mean. For example, I have two data sets. One has the scores 1, 3, 5, 9, 11, and 13. If we get the average or the mean, we have 7. For data set B, scores are 5, 6, 8, and 9. If you get the mean, it is also 7. So these two data sets have similar mean. But if we plot them and determine the standard deviation, you can see that even though they have equal means, they have an equal standard deviation. So ito, 7 yung mean. Okay? But if you're going to look at the distribution of the data, so ito, yung lowest score niya is 1 and yung high score niya is 13, mas malayo sila sa mean. Pero dito, sa dataset, yung pangalawang dataset, yung color blue, diba, yung lowest score niya is 5, yung high score niya is 9, mas malapit sila sa mean. So they have different standard deviation. So it's very important as well, no, to get the standard deviation so that we know how close the data sets or the values that we get to the mean of your data. In terms of variation, pag nominal yung data, we use frequency. For ordinal, we use frequency. So we both present them using frequency distribution table or histogram or bar chart. For interval and ratio data, what we use are variance and standard deviation. So those are the different ways to analyze the data in a descriptive way. Next meeting, we are going to talk about how are we going to apply inferential statistics in our research. So do you have any question? Do not forget to message me if there are something that you would like to clarify. That ends our discussion about descriptive statistics. Next meeting, we are going to talk about the inferential way to analyze your data. Reminders, please continue writing the chapter 3 of your research, answer subject quiz number 3, and reach out if you have any concern. You can message me via Neo, Messenger, text, or email. That's all. I hope you understand the lesson for today. I will see you all next meeting. Bye!